Did you know that Manual J can help you size a humidifier for wintertime? Let's take a look at how it can help us do that. Everyday living in a house generates moisture. We breathe, we shower, we cook, we have plants that put out moisture because we water them in the wintertime. All these things add to the moisture in the air. The problem is it's so dry outside, and when a building leaks, that dry air infiltrates inside and replaces the moisture that we've added through everyday living. So if we know how much infiltration is coming into the house in terms of CFM, then we can use this cool little chart on figure 27-4 in Manual J to figure out how many gallons of water that we need to add to the house by means of a humidifier per day in order to make up for that infiltrating dry air. So how many CFMs of infiltration does your building have? Well, it's impossible to know without a blower door test. A blower door will give you your air changes per hour rating to help you determine what your infiltration rate is. But let's say you don't have access to a blower door. Fortunately, Table 5A in Manual J gives some default values. So let's say that we're dealing with a 2,000 square foot single level house of average infiltration. You can see from this chart that our air changes per hour, or ACH, is 0.38. Let's say that in our 2,000 square foot house, our ceiling height is 9 feet. Well, we can now use the formula that you see here to determine what our infiltration airflow is. We know our volume of the space. That's going to be 9 feet times 2,000 square feet area, so 18,000, times 0.38 air change rate divided by 60. We arrive at 114 CFM of infiltration. Now let's go back to our chart and figure out how many gallons of water per day that we need to add to our building. So using this chart, we've arrived at 4.67 gallons per day per 100 CFM of infiltration. And we just calculated our winter infiltration rate at 114 CFMs. So we would need to multiply that 4.67 by 1.14 to find out how many gallons per day of water we need to add back into this building in wintertime to maintain 30% on a design day. This gives us 5.3 gallons of water that we need to add back into our building in order to maintain 30% humidity on a design day. That really isn't a lot of water that we're adding to the house. Even the economical humidifier models claim to be able to add 17 to 18 gallons per day. So a 5-gallon load doesn't seem to be a whole lot, but there are other factors to consider. Duct leakage is a huge source of infiltration because it's pressure-driven infiltration. Every time the blower comes on, if you've got leaks in your return duct, you are sucking in a large quantity of dry, cold, unfiltered, uncontrolled, unconditioned air, and that has to be accounted for also. The problem with calculating duct leakage is it's very hard to measure accurately because we only want to calculate the duct leakage in the return duct, because that's the path that dry air will enter into the house. The supply air duct leakage isn't really a factor. Well, how much of a factor is that? Well, it's hard to say. It depends on how bad the ducts leak and how often the blower runs. But it's pretty safe to say that on a really cold night, that the blower is going to run pretty much continuously all night long. So for that night, we're going to be pulling in all that dry air with absolutely no break. And our humidifier needs to be sized to be able to maintain humidity in that scenario. So Manual J also provides figure 3-6, default leakage rates for generic duct systems. If we don't have any duct leakage numbers to go by, we have to use this chart. For typical average sealed systems, so that's row number 3, we would want to use a multiplier 0.24 for our return leakage rate. Because remember, we're not concerned about supply leakage, we're only concerned about return leakage. So 0.24 times the square footage. In this case, it's 2,000 for our sample house. That's an additional 480 CFM of dry air that we need to humidify. So we would need to add this to the original 114 CFM of infiltration that we've already figured. That's a total of 594 combined CFM between duct leakage and infiltration. Let's just round it up to 600 because when we go back to figure 27-4, that's going to be an easier number to deal with. So if we're trying to maintain an indoor relative humidity of 30% on a 10-degree night, we're going to need 4.67 gallons per 100 CFM. And we're dealing with 600 CFMs. So we would multiply that 4.67 by 6. Now all of a sudden our humidity load went from 5 gallons per day to 28 gallons per day when we factor in duct leakage. So these other economy model humidifiers just aren't going to cut it anymore. No, we're going to have to step up to a higher capacity humidifier. That's why I prefer a steam humidifier. It has the capacity to handle a dry building, and it doesn't add to the heating load either. Something else to consider is that evaporative style humidifiers, normally the more economical ones that don't turn the water into steam and don't add any heat to the water, actually require a little bit more heating capacity out of your heating system. That's called humidification heating load in manual J, because as that water in the humidifier evaporates, it actually cools the air a little bit, and your heating system has to overcome that. But this video did start off acknowledging that humans add to the moisture in the home. And that's true. But think about when we need a humidifier the most. It's in the middle of the night when we're asleep. How much moisture are we really adding to the building? We're only breathing. We're not cooking or showering during that time. So good discretion needs to be used whether we really factor in that humidification that humans add back to the building or not. Most humidifier manufacturers actually give you a sizing chart. So you may think, why are we worrying about these calculations? Well, those sizing charts only include a very specific scenario, which may not be your scenario. If you undersize a humidifier, your customer is not going to be very happy, and trust me, you don't want that call. If you oversize a steam humidifier, it may waste energy because that water has to be warmed up all over again in between cycles. So it's really important to understand what goes into the humidification load of a building, and that's where understanding system design and looking at Manual J and the other ACA manuals will help you be a better contractor.